Okay, this time we're going to explore bubble sort. Now, selection sort goes and finds the next smallest item as we iterate through the loop and then swaps them from position to position. Bubble sort, on the other hand, continuously processes the loop in one direction, comparing the current item and the next item against each other repeatedly. So the idea of calling a bubble sort is that the process will go, okay, look, 5, 3, 5 is definitely larger than 3, so that's going to bubble up. So these guys would switch. The next comparison would be now 5 and 8. Well, 5 is not bigger than 8, so now 8 is going to collect, and then 8 to 4, 8 would then move up and move up until it hit 9. And one of the things we're going to learn about bubble sort is that there's really no way for the maximum value to float to the right-hand side or the end of the array when we're sorting in an ascending manner within the first pass. So the first outer loop will make the 9 end up over here, no matter what. And we can always guarantee that the next pass loop, the 8, and then the 7, then the 6. So we're really we're putting the largest available number in a bubble, and then we're floating it towards the top. This is still going to employ two loops that are one is nested within the other. So let's start with that. So in this case, though, we're going to have I be size less than 1 because our inner loop is actually going to look 1 ahead. So we want to make sure that we don't out of bounds ourselves. And you'll see that in a minute. Alright, so the next one is for int j equals 0. This one's a little bit more complicated. So it's less than size minus the current index we're at, minus 1. And this is because we know that on the first pass, 9 will be in the final position. So we don't actually need to continuously retest the last two items. We need to test up until the last two items. And you'll see this because we'll have a little debugging example that'll walk us through that. And I didn't have an incrementer. Now, the other thing that's really drastically different is that now we're going to make all of our decisions strictly about j. So really all we have to do is compare the current item and the item to the right of it. And if the one to the left is larger than the one on the right, then we're going to bubble or swap them. So we can do something like if our array at j is greater than our array at 1 greater than j, then we'll go ahead and do a swap operation. And this is very normal. So we're going to make a temp variable. That will capture the variable or the value that we're moving. And then we'll reassign the value we're moving with the one we're swapping it with, which is the one we were looking ahead at. So that's the +1. And then we'll put our larger value now on the right-hand side. J plus 1. And then because sometimes this data can get a little messy, let's line up our equal sign so it's nice and pretty. So at this point, that is effectively the entire bubble sort operation. So it's a fewer lines, a little more complicated theory. So let's put a little output just so we can verify that this actually sorted correctly. So we'll need another for loop. And we'll drop in a little output statement. So we can verify this. And Oh, semicolons. Got a little over exuberant there. So here we show our unsorted array is now sorted properly. What's really cool about bubble sort is that if we want to sort in the opposite direction, all we have to do in this case is change the sign. That's much more convenient than in selection sort, where we have to effectively start at different ends of the array. Alright, now let's just watch this thing in operation, because that's the true majesty of it. So I'm going to use the debugger to do this. I'm going to drop a break line at the end of our inner for loop. So that means that this will be after any swapping happens, at each time our for loop completes. Actually, we'll put it right here. This makes sense. Alright, let's launch the debugger. And then what we're going to do is we're going to watch the unsorted array. So you're going to see these are going to change color. When they're blue, they're going to change their value. So let's observe what's going to happen with 3 and 5 as we step through it. So 5 hit 8. Now 8's being carried up. As we see, it's like it's at position 5. Now 8 hit 9. So that's nothing swapped that round. Now we're going to move to the next one. 9 moved from position 6 to 7, and then to 8, and now it's in position 9. Now we're going to do the next of the I loop. So now we've caught 5 again. We've swapped 5 and 4. 5's going to keep on moving until it hits 8, and then we're going to pick up 8 and we're going to carry that down. Now you notice that 7 and 8 is already sorted now. We're going to have to check it again, because that's unfortunately the nature of this. It's not going to detect the sorting if it's already become naturally sorted. Alright, so now we're carrying 4 around. Which then we picked up 6. Now 6 is in position. Now we finally had 1 and 3 swaps. Now we notice that as we bubble sort operates, the outer sides of our array become sorted before the inside. Also the most expensive part of this array will be getting 0 from position 5 to position 0. Because aside from 0, we are there. And so now we'll have to go through the entire array a number of times where nothing gets swapped until we can keep moving 0 to the front. This is the most expensive operation that's happening. But we're almost there. So it's going to pass one more time and then we're done. So that is the bubble sort operation, which is an extremely efficient one. It's interesting for getting maxima or minima rapidly, because you know that you'll get that on the first iteration. It's better than selection sort on larger data sets, but these are still not the most efficient sorting algorithms. But they are fun to play with. So, hope you enjoyed.